Welcome everybody. This is a Iliad webinar series webinar, and today we are going to give you an overview of some of the many resources that we do have available in Europe for building digital twins of the ocean. And we will give you a few examples, also more concrete examples from what we have developed so far in Iliad. So that's the program for today. My name is Bente Lilja Bye. I'm, as usual, the host of the Iliad webinar series. I am the innovation manager, and I'm doing a lot of other engagement and also some technical work in Iliad, and in general, very much interested in data sharing and making data and resources interoperable. So this is close to my heart. Now, I will start by, well, first of all, mute yourself if you're not speaking, which is most of the time only the presenters. But we do encourage you to write your questions and comments in the chat. We will answer questions after the presentation, so at the end of all the presentations. But write while you have them on the top of your head, and then we will give you the floor also to ask the questions afterwards, because we want to really encourage creating and maintaining this vibrant community, after all, of ocean twins here in Europe. I will start by showing you the program. So I will share my screen here. I'll put this in slideshow, and you will be able to see the title of today. This is part one, by the way, because there are so many resources, and we do want to invite more partners and collaborators from the representing many of the other resources also, and of course show more of what we have to offer you from Iliad. So here is the program, the agenda for today. We are in the midst of welcoming and the introduction. Then Arne-Jørgen Berre from SINTEF will give us an overview of interoperability opportunities with EDITO, Destination Earth, EOSC, and the Green Deal data space. Then we will go to a couple of examples, more concrete examples from Iliad. First, examples of using application packaging in digital twins of the ocean by Antonis Parasyris from the Foundation for Research and Technology in Greece. And then we have the Ocean Information Model Development and Implementation by Raul Palma from Poznan Supercomputing and Networking Center. And then all of you in a discussion. So moving on to what we mean by digital twin, what we mean what we define it, how we define it in Iliad is that it's it's a replica, it's a digital replica of the ocean and its components. I will come back to that. And it provides, this digital twin provides a virtual environment representing the ocean, and it's capable of running complex and predictive management scenarios. And it's an innovative system that integrates across many disciplines, sensors, models, and digital infrastructures. And characteristics of a digital twin that is more than just a model is that it is interactive. You can interact with a digital twin. It's also a loop where you can constantly feed it with more data and information so that you improve the accuracy of the replica, if you like, and you can also run different scenarios. So what we see in Iliad is that we want it to be interoperable. So interoperability is key. It's data intensive, of course. And we are also, since we are an innovation action, we are also focusing on the cost. So cost effectiveness is also a key for how we are seeing digital twins in Iliad. So as I said, our concept, approach or concept is to realize and appreciate that the fact that the ocean is very complex. It has many components, geophysical, biological, and numerous interactions between them, and also the human activity. And this is what we are taking into account. And the second point here you see is that we are building the digital twins based on existing resources, and we are adding also new resources from the European ecosystem of now what we call the digital twins of the ocean resource pool. In order to succeed with this, we need to have established and nourish partnerships with other activities and communities and organizations, and align our approaches. And we create then interoperable systems. So in the seashell, we are enabling an ecosystem of interoperable digital twins for the ocean through using existing resources, and enhance these resources with more data infrastructures and observations, including citizen science. We are offering this in a marketplace where we are offering both, where you can find both the twins themselves and the individual components. And it's not only for Iliad, it's for the entire community around digital twins. So you are all welcome to use that. And of course, we are also, the twins themselves are providing solutions to some of the societal challenges related to the ocean. So that's Iliad in a seashell. We are talking about multiple twins. Our twins, Iliad twins, we are dividing them into different segments, so thematic segments. And you see there, currently there are 12 that really address specific challenges. So existing, we have wind farm capacity, ocean energy potential, coastal sediment transport, plastic pollution, oil spill situations, insurance for maritime and marine and maritime activities, jellyfish swarm forecast, harbor safety, metocean hind now and forecasting, fisheries productivity and sustainable aquaculture, ballast water monitoring, and aquaculture and harmful algae water quality and ship traffic. So you see the twins that we are building in Iliad are very thematically focused, and also a local solution. So this is really distinguished us from many other twins that are being developed. For instance, EDITO that Arne will talk about, and also Destination Earth, they are more general and something that we can both benefit from and also contribute to. And Arne will talk more about that. So I said that we will present today some of the resources we have developed, some more technical resources. The Ocean Information Model is one of the resources that we offer to the community, and Raul Palma will talk more about that. It's based on best practices and standards, and it's harmonized and functioning as a harmonization tool. Then the second technology or the tool that we will that we are offering and that had developed here in Iliad is the application packaging for twins. And an application package refers to a comprehensive collection of software, resources, and specifications bundled together and designed to distribute and execute specific data processing workflows. Keep this in mind when Antonis is going to give you some more concrete examples. We're going to talk about application packaging in a registry, demonstrator, and you will see concrete examples today from that, just to give you a bit of a teaser and an overview. So very quickly, Iliad is about to conclude. We will end in the end of July in 2025. We are 56 partners. The budget is with the contributions from this partner. Some of the partners, many of the partners are close to 19 million euros, 17 of them from the European Union. So you see, it's a huge endeavor, and obviously we have a lot to offer, and we are eager to continue to collaborate with the community around us also in the future. So with that, I will end my presentation, Arne-Jørgen, and then you can talk a little bit more about some of the key actors in our ecosystem. So Arne-Jørgen, by the way, Arne-Jørgen is our science manager in Iliad. He is also a senior scientist in the SINTEF digital and has a very long track record for participating in the various EU projects. He has substantial experience in standardization work, and since he's a senior, so you cannot list everything you've done, Arne-Jørgen, but I know that interoperability is close to your heart as well. So the floor is yours.
Thank you, Bente. So I will not talk very much about Iliad, but talk about it in the context of interoperability in the European Digital Twin of the Ocean ecosystem. And it is indeed an exciting time now, because now it's not only PowerPoint slides anymore. We have operational platforms available from EDITO, from Destination Earth. We will soon have also from European data spaces. We have already from EOSC and also with Iliad. So the pointers of references here are actually to working operational platform that you can check out. So I would urge you to do that. I will come back to what they contain. We'll talk today of the oil spill pilot, or two of those from Iliad pilots, which are, say, local digital twin for oil spill. The architecture, which is overall behind all of the various digital twins of the ocean and in Iliad, is following this digital twin pipeline from data acquisition, from sensors observation, from satellites to UAVs to sea surface and subsurface, and also using a lot of different sources from various so-called data spaces, as we start to call things now. We'll talk in particular about the Green Deal data space for geospatial related information and environmental data, but also citizen science data, biodiversity data, socio-ecological data are sources that we bring into the different digital twins.
Arne, are you
yeah.
sharing? Are you meant to share your screen?
Yeah, I'm sharing. Maybe I need to acknowledge
I don't
something.
see it. I don't see it.
Okay, it says I saw this blue area around it. So let me try to do that again. And now I can maybe try. Let's see there.
Yeah, it looks promising.
No, okay. So there we have that start. And here is the link to these different platforms. So now you see that, I think?
Yes, very good.
Okay, very good. So EDITO, Destination Earth, the coming European data spaces and the Green Deal data space in particular, the EOSC node, and also from Iliad. As I mentioned, we have a number of digital twins, and we'll talk about oil spill as an example later. As an overall architecture, we have this digital twin pipeline of going from data acquisition with data from different kind of sensors, from satellites, UAVs, surface, subsurface, and from various collected aggregators. We have Copernicus for Sentinel data, EModet and SeaDataNet from various marine data, evolution of EOSC as a data space, and then we have the Green Deal data space for geospatial and environmental data and various sources that we have in projects. With all of this data, there is a need to do semantic harmonization and support interoperability of those sources, and this is what we'll talk about later today with the Ocean Information Model as a support service for that. As we bring the data into repositories in terms of data lakes, we will have some data lakes in Iliad for different twins. We assume a number of twins, and we'll look at also interoperability among twins here. But in particular now we have data lakes for digital twins coming from EDITO and Destination Earth. and they are also relevant in this context with their supporting digital twin engines and services. So we will look at these as they now are emerging, and with the perspective that what we will talk about also in coming webinars are in more details on the interoperability in and between these environments. Within Iliad, we have also the Ocean Data Platform as one of the representation repositories with cloud services support for application execution and processing. So this is also one domain that we'll come back to when we talk further about Iliad environment later. And then we have the approach towards interoperability, not only technical interoperability, but semantic interoperability to the use of the ocean information model that was presented shortly by Bente, and we will hear more about this from Raul later in this webinar today. So now I will talk about what's happening around Iliad, and in particular now it is the first version of the EDITO infra core platform that together with EDITO Model Lab will be a foundation for a public core service for European Digital Twin Ocean with a data lake and a digital twin engine, and an architecture where a lot of initial focus is to bring data, in particular EModet data and Copernicus Marine Service data, into the data lake to be close to the compute infrastructure for optimized performance in cloud and HPC, with the support then for models. So we have this underlying infrastructure supporting that being operational now. And as a basis for running virtual research environment, Jupyter Notebooks or RStudio and Galaxy and other virtual research environments with associated models and links to AI, machine learning, and collaboration around the models. So it follows the same structure, and this is now available in beta release with 3 levels of access from Explore, Create, and Contribute. And the Explore is open with documentation. For the others, there is a need for applying for beta testing before it becomes more widely available next year. But the point is that this is now specified, and we see how it evolves with the various elements of the services according to this architecture. There is a service catalog as well as a process catalog with operational processes and availability of various technologies such as Jupyter Notebooks. One important point to mention, or look at architecture, is the use of spatial temporal asset catalog with Stack and browsing of data for that. So it's possible now to explore this. And of course, that's a good milestone. We had that since the summer, and it goes now into beta testing in September. And it's based on the same architecture as I outlined before. We have data coming. This is from right to left. So we have data from various sources, and in particular, a focus on spatial temporal asset catalog, Stack technologies, with optimized ARCO formats, analysis ready cloud optimized, such as ZAR, as we see here, or Parquet, and the use of NetCDF with CF conventions that can also be mapped into this for optimized cloud performance and distribution. Support in processing with Dask and Spark and related technologies, and support also for virtual research in our environment, such as Jupyter Notebooks in RStudio and similar. There is a workflow technology here that is somewhat HPC connected, auto submit. We'll hear about application packaging in Iliad with CWL later, common workflow language, but this can be harmonized and are elements that we are looking at in the European Workflow Hub, where we can look at different workflow formats and their relationships and synergies. So this is the principal architecture related for interoperability with Iliad. We are following the same architectural principles with the data lake and the digital twin engine and services. In Iliad, we are putting some focus here on handling various types of data from the data space context and from sensors, also real-time data streaming with the stream handler, and are looking into the synergies with the emerging European common data spaces in general, and in particular with the Green Deal data space that is now being going into implementation phase, and data space middleware such as Simple, all also in the context of support is with semantic interoperability and the ocean information model, and federated catalogs with semantic discovery of data. So these are a little bit extensions that we have in the front end with Iliad, but it all goes into the same context of bringing data, this is here from left to right, into the data lake, so it can be harmonized and made available for the processing. The same principle and architecture as EDITO is having here and that's relating to is also being followed in Destination Earth. And Destination Earth had a release of the platform in November, and yeah, already from October with the third user exchange meeting in Darmstadt that made available the platform. So this is something that you know can get access to, also on different levels of access, but a lot of information is available there now. And architecture is following the same principle of data going into the data lake to support the different digital twins. And there is already a climate change adaptation twin and a extreme weather twin. And there are 3 new twins that are getting funding from next year, evolving from this, and also the digital twins of the ocean, with EDITO as an example here, is being harmonized into this. Note also that data spaces are surrounding the data lake, and these red circles, such as the health database or mobility, or indeed the Green Deal data space, which in addition to other data sources will be the foundation of the data that will go into the data lake or the lakes for the different twins. This is being integrated with HPC, in particular for Destination Earth. So with Euro HPC, for typically with the weather forecasting, we know they are large users of HPC simulation. This has now been extended also with AI and machine learning and large multimodal foundation models, which have shown that they actually can speed up and facilitate efficiency in the context of the large classical simulations, and a combination of this will be supported with bringing data from the data lake into selected data for the HPC storage resources. So this is the data lake here, which has a number of services, including harmonized data access for many of these different sources. And again, is using STAC, Spatial Temporal Asset Catalog, as a foundational structure with a corresponding STAC API. There is actually 2 stacks here. Is the Spatial Temporal Asset Catalog is actually the software as a service suite for doing service processing with Jupyter Hub, Dask, and DataCube. So that's a different stack, and it can be confused by those two, but they are very different. And then also how to do additional computational and storage access with S3 buckets and supporting storage systems, both centralized and at the edge for the processing. So this platform also became available now and has interesting data related to particular climate adaptation and extreme weather, which is unfortunately quite relevant these days for many projects to relate to. So in the context of interoperability, we see that the same architectural pattern here. There is more work to be done on the data space integration. It's really the next step for next year, as we'll talk about next with the Green Deal data space as an example. So there are more They are not operational in the current platform, but they are now the next step on the agenda. So the example here is the Green Deal data space that has been specified through the GREAT project, which is a Digital Europe project. This is going into the implementation phase now, early in 2025. And one thing to note here from the Digital Twin of the Ocean community is that there is an objective here to support stack and coverage and raster, as we see in this cube representation and coverage with X-ray or Parquet and ZAR and coverage-oriented formats, as typically stack is focusing on, but also the need to support vector and vector representation and the classical geospatial APIs from OGC and TC211, including also semantic representations. And these are some of the inputs that are being brought into the implementation of the Green Deal data space, also with partners here from Iliad, and also the notion of an ocean information model enhanced here as an environmental all data for Green Deal information model with some of the same technologies as Raul will talk about later under the ocean information model. In addition to this, there is the simple middleware that is a procurement that will have its release of a first MVP in January, end of January. It's a large project that are composed of 3 parts, an open software stack, the simple labs and the simple live, which will be supporting different data spaces, not only the Green Deal, but also others, and interoperability between. So, the release presentation of the MVP is end of January. So this is a forthcoming technology to look out for, and will be relevant in this data space architecture, as I showed you. Finally, we have the European Open Science Cloud with the EU node that was released, presented now in end of October. And this is something that is available for everyone with an academic account in European countries. You can use your regular academic username and password, and you will get into the EU node with opportunity to access the services that are fairly basic cloud services, essentially, combined with efficient data management of large data files with file sync and transfer, large file transfer, and bulk transfer. Container platform with virtual machine and supporting interactive notebooks such as Jupyter Notebooks. This is one of many nodes that will evolve. So the EU node is essentially a reference node with rather limited resources in terms of credit points that you can get for compute and storage. But the strategy of the EU Federation is to have both national nodes and thematic nodes with additional resources being interoperable. There will also be links here to Simple and data spaces and EuroHPC. So this is a forthcoming infrastructure that will provide us with compute and storage resources that again can be kind of an infrastructure host for various digital twins, and we can see the synergies of this in the future. So coming back to the conclusion here, these platforms are not plans anymore only. Well, they are still evolving and more work will be done, but now they are available on the following references, as I gave also earlier. And I suggest those with an interest in this area to actually take a look at the platforms. Indeed, Iliad is now working with, in particular, EDITO here to look at how Iliad and EDITO can have an optimal interoperability. But also these others will have elements of support in the larger ecosystem on digital twins of the Earth and digital twins of the ocean in particular. So that was the intro I was giving to this, and we'll come back to actually more details of EDITO Destination Earth in some of the coming webinars that we have announced for the DTO resources. So this was the intro and kind of marketing to come back to get more of the details and examples and demonstrations.
Yeah. Thank you very much, Arne-Jørgen. I Well, I asked, before we move on, I asked you all, by the way, the slides, can you make a PDF perhaps, Arne-Jørgen, and send it so that we can make it available to our audience? Be great. Yeah, thanks. While you were...
Just one thing to note, actually, in addition to the platform itself, the Destination Earth third user exchange in October has a link here, and all of the presentations are recorded and available. The same for the EOSC EU node with the EOSC symposium in Berlin end of October. It's recorded and the slides are available. So a lot of these details are available for you already now if you want to go to these links and find it there.
Yeah, thank you very much. This is one of the purposes of the the goal of this particular type of webinar now is actually to help people find all of these resources that we do have in the ecosystem. So thank you very much for that, Arne-Jørgen. I will share. I did a very quick poll while Arne was speaking. A simple question: are you developing a digital twin? And as you can see, a little bit more than half of us are doing that. And the other, I guess, is very curious on how to build a digital twin. So thank you for participating in the poll. We are indeed, we are making an effort to create a community around developing digital twins of the ocean specifically. And we are very happy that you are with us today and that we can share and benefit from each other's experiences and resources. So the next coming up is the next speaker is going to be Antonis Parasyris from the Foundation for Research and Technology, FORTH, for some of you who know the acronym. He's going to show us some examples of using the application packaging that you got a little bit of taste of in digital twins of the ocean. So Antonis, the floor is yours.
Hello, everybody. Thanks, Bente, for the introduction. We are working at FORTH on two pilots within Iliad. One of them is the oil spills forecasting and identification. And these are some of the partners that have helped us in this endeavor. This is the structure of my talk. Today, I'm going to give a little bit of introduction to this pilot and the subcomponents that it has. And then the challenges we addressed by application packaging, which is recommended as the best practice for this type of work within Iliad. And then I will give you some examples for the application packaging in a command line tool fashion. And then I'll give you the entire workflow pipeline and how it should come together to construct the pilot. And I will discuss some lessons we learned from this journey. So a little bit about the pilot. It's concerned around the island of Crete, where we have high resolution models of forecasting oceanic and atmospheric states. And this is an area of high economic interest with recent exploration and exploitation activities for offshore oil and gas. So the stakeholders, which might be that oil and gas companies are interested in this kind of applications, as well as the Hellenic Coast Guard and Port of Heraklion authorities to forecast the fate of an accident on sea. So this environment aims to provide near real-time oil spill detection and forecasting, produce early warnings when an oil spill event is identified, and provide on-demand service to users for simulating what-if predictive scenarios. Here you see that this pilot is using the atmospheric models with these variables on the left. And it forecasts trajectories, oil weathering, and beached oil, ingesting data from satellite as well to see here on the left images from satellite and identify when this is an oil spill and be able to trigger the model. So by application packaging, we have many advantages in comparison with just running the models. The first one is reproducibility. The users can are able to test and validate workflows, have different what-if scenarios and run them easily. And there is portability as well, where you can run it in different geographic regions, and depending on when the SAR image is identified to have an oil spill in them. And you can also have interoperability. You can run them on different machines, on HPC, on cloud computing, because all the libraries necessitated by the application packages are already predefined. So you can switch machines easily. You have modularity. I will discuss a lot of this later on, where you can split the workflow into separate components, and this is very important to reuse those said components into other workflows as well. By having these application packages, we have created the catalog, which is very important since the application packages are discoverable by everyone. This is a free accessible catalog. And there the users can access the metadata of the application packages, which describe what are the inputs, the outputs, the contributors, the institutions that have created those application packages, etc. And there is the ability of versioning, so there is importance in uniquely identifying between update versions. You have seen in public platforms like GitHub and Docker Hub, where you have different versions and you need to specify which one you are interested in. And then this application packages also provide security, where you can either lock with passwords or have limited access to be able to commercialize those application packages and keep the Docker secure. This is an example of the application packaging in the registry, which is maintained by NestTech, a partner from Iliad. This is a simple example of a global application package. Hence, here in the map on the left, you see the entire globe. If it's specific to a region, this is within a bounding box. And this simple tool just cuts from a global bathymetry file and gives you, with an input that you see here on the right on the inputs, you specify float type numbers to be the bounding box of the area you want to cut it. So this is a simple introductory example of this application packaging, where this is a command line tool, and this is what the CWL actually looks like. You see here on the left, that's a command line tool, usually using one Docker. You see the inputs and outputs, which here the output specified to be netcdf with a specific compliance. And then you have the Docker requirement, which is the Docker behind this CWL that is pulled to run the command that you want to run. This also has specified versions here, as we can see. And this is how easily one can run this CWL tool. Only thing that's required is a Docker engine and the CWL tool itself. So I don't know if you saw it. Yeah, you just write this command that I have it here on the top, where you specify, you don't need to download even the CWL file. You can specify the link where you found in the registry, the ID, and then you insert your inputs as numbers. And here you can see this has run, and then the output can be visualized if it's an ANSI file like so. Now we're going to the more the thing that is most intriguing about CWL to me, at least, that it's a workflow, which is a series, an orchestration of a series of command line tools, where it's the same format as the one I showed before, but here we have a class workflow, and you can specify steps where the ID is here, for example, the bathymetry that you saw earlier, with specific inputs. And then on the output, you specify then on the step 2 for the one application package to give its output as input to the next step. So here you can be as creative as you want and combine and pick and choose what kind of workflow you want to create for what purpose. You can also have visualization steps, etc. In the next slide, you will see the pipeline that we have created for the oil spill identification, which is the first part of the entire pilot. And this has two alternative versions. It's split into 5 application packages. So the first one, for example, does the data search. It searches for satellite images and then downloads it. And the second one pre-processes them to be inputted into application package 3, where you have the object detection, where an FCOS algorithm is running in the background and bounding boxes of possible oil spills are identified, which are then passed to either application package 4 or 5. So what's the difference? They're both for segmentation. They take the image of the possible oil spill and they pass out an output TIFF binary mask. And the application package 4 is created by MEO, which is our Iliad partner, by using a UNet neural net. And the application package 5 is just using the snappy routine, which is a Python tool. So in this way, you have created 2 possible alternatives that both output oil spill mask images from SAR data by combining 5 application packages. This is an example of how you visualize then in any GIS software the output of the binary masks. So you see here with yellow and red the different application package outputs, which are above the Cretan Sea. And then the entire pipeline consists of these 5 Dockers. We use 1, 2, 3, and 4, using the UNet as an example. And then you feed this into the pipeline into the oil spill model as an input, which is also Dockerized, the Metzlik model. And you can also use the bathymetric cropping software, that application package that I showed earlier, to reduce the size of your images, the files that you input, which improves computational speed and reduces loading times. Also, in the Docker that runs the oil spill model, you can input data from a data lake, which from us is Adam API, and we have also shared FTP that you can pull data inside the Docker, and this then when you run it in the CWL pipeline, the orchestration automatically updates with specific inputs of the time when it's forecasted with the appropriate what-if scenario, integrates the Metocean forecast data. And also this, I should mention that these are the 3 models that we run for the forecasting, which is downscaled in this resolution. But if the oil spill is outside of the bounding box of those around the Cretan Sea, public use CMEMS and GFS forecasts are used in a global scale. And this is what an output in GeoMachine looks like, where this is a platform, a server that has created the visual front end of the pilot, where you can insert an output from the entire pipeline, which is a netcdf file. You can give it a unique reference title, so you can load it afterwards. And as you click generate, you get this message. Depending on the server load and the file, the size of the file you upload, it can take up to 10 minutes, but I think this example is around 1 minute loading time just to load the specified output from the pipeline. If I go a little bit faster, yeah, this is the output that we get on top of on Cretan Sea. And on the left, you can select hours, where you're forecasting into the future, depending on the Metocean and the run of the Metzlik. And you can see where it will go and how quickly it will go there and when it will be beached. For example, this is an open sea oil spill, so it won't get beached in 24 hours. So this is the end of that simulation. And you can load other simulations as well by running the Docker, the whole workflow of the Dockers. Some lessons learned from the application packages. The first that I couldn't stress enough is that making CWL as simple components and then uniting them in a big pipeline is a very good practice because it's a modular design that aids reusability, which is important to save time and broaden the use cases of your work. For example, the bathymetry that I showed you might seem simplistic, but it's also used in our optimal SIP routing pilot, where it reduces the global bathymetry file size and can be adapted to run in different SIP routes. Another lesson learned is that we need unique versioning in the catalog, where at the first stages or iterations of the catalog, there wasn't any versioning, so it created duplicates depending on the Docker that it's run. But as platforms like GitHub and Docker have versioning, it's important to have it in the catalog as well. The third one is portability, which is important specifically to modelers, as we have discovered, because many times we need to change the environment where we work on. Either it is a HPC to be a little bit faster on the computation side, or you need cloud computing. This is also making a research collaboration easier. For the SIP routing, for example, we were requested by another Iliad partner to also reuse the code in their area. So it's much easier to share a CWL file and just change the input in the input file. It's very easily used, as demonstrated here, with just one command for the CWL, and it's the same when you run an entire pipeline. So this also boosts the public outreach. Many users might be interested if they see how easy it is to set up your own scientific tools for application like that. And so it broadens the end user target group. And lastly, it's very important for the metadata and documentation to be included in the catalog, as it enables the user to run it and has all the information there for the input and outputs and what exactly the tool does and what region it's about. That was my talk. Thank you.
Thank you so much, Antonis. And I'm just, as you were finishing, you just give me the seg to plug the GEO, the Group on Earth Observations, in GEO and FAIR self-assessment tool that creates good data management plan, because you just gave a very good argument in your summary there, how important it is to have good data management. And for many reasons. So everybody is saving time, and you can, for reusability and reproducibility, this is absolutely key. So thank you for that. We just had this webinar this morning on data sharing and data management, including introducing this self-assessment tool. I can warmly recommend you to follow and to become a part of that community, because if you are interested in developing digital twins of the ocean, this is absolutely going to save you a lot of time. I just wanted to say that. I will provide links in the chat, and I believe also, Antonios, your pilot is a very good candidate to be presented on the Geo Knowledge Hub, where we actually go step by step, explain exactly how you can reproduce what you have created. So in addition, of course, that everything will be available on the Iliad marketplace. With that, so thank you, Antonios, very much for that. We will learn a lot more about not only the example that Antonios was giving now on some of the twins. We will have demonstrators of more than 20 twins next week, when the Iliad has a general assembly, and after that I'm sure we will share the joy of these results with you and come back to you with more examples. As Arne-Jørgen was saying also, that we will continue to have this type of webinar after New Year's. Now, Raul, are you with us?
Yes, hi.
Yes. So Raul Palma is
Okay.
going to give us the next presentation. He is the head of the Data Analytics and Semantics Department of the Poznan Supercomputing and Networking Center. Many of us knows it as PSNC. I just wanted to spell it out. He is very experienced on data modeling, knowledge representations, and discovery, data integration, open link data, and semantics interoperability, and is one of the leading experts on developing the ocean information model, I dare say, Raul. So the floor is yours.
Okay, thank you, Bente, for the introduction. So I hope that you will hear me well. I am in the middle of an event, but I hope that it will not be noisy. So yeah, I wanted to talk today a little bit more on the latest developments and implementations, adoptions of the ocean information model as part of the Iliad project. So I given already several talks in the past about the model itself, so I don't want to go into too much details here. I just want to remind what is the purpose of the ocean information model. Basically, its goal is to establish the basis of a common ocean data space that will enable the interoperability of different systems and the analysis of the data produced by those systems in an integrated manner. OIM was, designed and implemented in a modular way, following a layer architecture, as you can see on the diagram on the right. It's basically including different layers from the top, starting from the core meta model layer to the cross-domain layer, domain-specific layer, pilot-specific layer, and metadata layer. All of those models were implemented by reusing and extending, when needed, existing standards as much as possible. So whenever we were able to reuse a standard from OGC, from ISO, W3C, we were trying to make them as part of the model and aligning them. So one of the main features or value features of the OIM is basically the alignment of existing standards. So the ontology, the model has been implemented as an ontology, formally, but of course it also includes some other semantic artifacts like the JSON-LD context of the ocean information model that allows, the exchange of data based on the very commonly used standard of JSON. And also we are, providing the something that is called the shackle graphs that allows the validation of data at the semantic level in order to see the compliance with the ocean information model. Everything is open, is in the GitHub repository of Iliad. And also it's based on the permanent identifiers, which is the main namespace is the one that you see here on the screen. One important point about the ocean information model is that this is part of a family of information models that we are developing in different domains. And all of them are sharing the same higher level layers. So, the core, the cross domain, all of them, the metadata layer, all of them are, reusing the same kind of layer. That exactly will allow us then in the future to really boost interoperability with different other domains. For example, I think Arne was just talking about the Green Deal data spaces, and we are also, producing a similar model based on the same standards as the Green Deal information model. So that is also complying basically with the rest of the architecture of the ocean information model. So one of the most important things I wanted to just focus today is in the alignment with existing vocabularies, basically the connection to essential variables, or for example, the worms code list, which is basically the name of marine organisms that include information of synonymy about these organisms, but also, those vocabularies like the climate and forecast for representing variables of climatic data that are also relevant for the Iliad domain, or even AgroBook, of course. So we provide the mechanisms to connect and align with those standards. One important point is also the metadata layer, because in the last period of the project in Iliad, we were working a lot on the creation of a Iliad schema application profile, so that we would be making sure that all the different pilots can provide their data set and describe their data sets in the same way. So obviously, like mentioned before, the metadata itself is based on existing standard like DCAT and extensions like GeoDCAT and Quality DCAT, but also other models like the IDS information model and additional some extensions for OGC, the coverage implementation schema, and some additional elements that were necessary for Adam platform. So how is in terms of the implementation? This is, what I wanted to work a little bit more here today. Basically, in order for you to start working with the ocean information model, there are different entry points. First, of course, the possibility to find terms and retrieving annotations like reference terms based on the ocean information model. So this model is available in the biodiversity onto portal. So there you have the possibility to navigate the classes, the properties, instances, and so on. And it also provides the possibility to generate from some text annotations that are linked to entities in the ocean information model. So that gives you some entry point, some like a starting point, how to use the ocean information model. Once, of course, you know how to use it, then you start generating JSON content. Of course, we are assuming in most cases here in Iliad, most of our services are exchanging data based on JSON. So we are just adding the LD part, which is adding the semantics to the JSON. And these semantics are the ones defined by the ocean information model. So in terms of the JSON developers, this will not be that much a difference. At the end, it's JSON content. I will show you in a second. But it allows us to connect to the semantics that is defined in the ocean information model. And then based on that, of course, we can do validation of the data. So here is an example how this JSON LD is generating. Basically, we have on the left side of this diagram is the context that is generated by the ocean information model. And on the right is an example how to use this context. So it's in a JSON content. So basically you see it's a context is just pointing to the content, the context that is defined by the ocean information model or any of the ocean or other information model I mentioned before. And then the rest is basically providing a typical JSON content. But the difference is that all of the elements in those JSON payloads will be actual terms that have some explicit semantics defined in the model. So here, for example, are some representation of data coming from some pilots. Here is from the jellyfish pilot in Iliad. So you can see how data is represented according to the ocean information model, where you have collections of observations, which have associated properties. I mean, what is the observed property that was measured? What are the procedures? What are the feature of interest? The sensors associated, and so on. And of course, the results. So what was the actual measurement and the units of the measurement? All of these elements that are important to represent that information in the ocean information model have been, providing like a high level view on this diagram. But similar thing can be done with other pilots. For example, this is from the oil spills as well. As you can see, they have like similar structure. And this structure is based on the semantics of the ocean information model, which in turn is based on standards. So in this case, the standards are coming from the OGC, SOSA, SSN, measurements ontology. So that gives you this, observations collection, observations properties, the sensors, and so on. So one example here is about the metadata itself. As I mentioned at the beginning, one of the key tasks now that we have been working on is the creation of the Iliad metadata schema application profile to generate the pilot dataset. We started like a definition, of course, in some CSV format, some CSV sheets online. Based on that, we were able to generate some JSON schema as well. So that was a simple way of facilitating the quick validation at the semantic and partially semantic and syntactic validation of the data. And this is an example how the data of data can be represented based on this schema. So how is then the actual generation of the data based on OIM? This can be done in many different ways, many different approaches. Of course, the services themselves can provide data in OIM format, or in some cases, for example, when the data is available, like the dumps or whatever, we are able to do some kind of transformation process, harmonization process that do the semantic lifting of the data from the original source to the ocean information model compliant form. So we provide some tools that are based on the data preparation and integration pipelines. This is based basically on linked data. And in practice, this is implemented as tools as a CLI tool, as a web service tool, also web interfaces for the users to work on this. But at the end of the day, you know, this is not the tool for the final end user. Normally, this is for the data provider or, you know, solution provider that will support in the harmonization of the data into the ocean information model. But that's not the end of it. Once we have the data in the ocean information model form, how to access this data, there are different possibilities as well. One of the main approaches that we are doing in Iliad is to try to also provide standard interfaces, particularly here following the OGC standard web APIs that are available on the web. So one of the main services that we are providing in Iliad is the OGC Sensor Things API generation service that can create automatically a standard interface, OGC interface, to data from observations or measurements. That is, of course, based on the OIM form. So if the data is compliant with OIM, we can generate automatically a standard OGC API to access this data. But it's not, of course, the only way of access the data. You can, of course, have like, you know, user interfaces like the one that you can see here that we created for the jellyfish pilot, but also navigate the faceted browser of the semantic databases for Iliad, or you can even, of course, create your own queries. But it's, instead of SQL for relational databases in the semantic world, this is called Sparkle queries. And finally, I just wanted to mention here another example that we are working on now, which is the connection with other Iliad components. Also, Arne mentioned at the beginning the ocean data platform. That is one of the components of Iliad. So in our ongoing process is that data is coming added to the platform in the original form, like the one that you see here. This is an example from the cultural heritage in Israel. Then based on this, the platform will automatically provide the possibility to harmonize the data based on the ocean information model. This harmonized data will go back to the ocean data platform. So you will have the possibility to download, you know, the original data, but also the harmonized data. And once, of course, the data is harmonized, again, you can find all of these different interfaces, like the web interfaces, but also in this, at the bottom, you see also, this is another OGC API interface. This is for futures API, because in this case, this is cultural heritage. This is not measurements. These are information about places, sites in Israel. So this is the future API that is the standard that gives the possibility to access this data. So yeah, so that's from my side at the moment. Of course, anything that you would like to know more, please contact me at any point in time.
Thank you so much, Raul. It's very impressive work. And I think it's illustrated that many communities are actually contributing and engaging in this activity, in developing the ocean information model. Sorry. Now that we have come to the part of the discussion, and there, as you might have noticed, there's some activity in the chat. I'm very happy for that. But in addition to the writing in the chat, I suggest that we actually give the floor to those who have made some comments, and then also to the answer. There have been some questions and comments and answers. So I don't know some Di Hamal Mandalia. Are you able to join us to speak? Are you still with us? Yes.
Yes, Bing. How are you doing?
Hi. Thank you for your engagement. So you have you tried actually to connect to the EDITO platform. And what was your experience? And then Arne, he can give you some direct
Yes,
advice
I
also.
did
Yeah.
respond because when I say that the platforms are operational, it means not that they are openly available on all levels. In particular, I show that there are 3 levels of access. And the first level is already when you enter, and you can get access to a lot of descriptions and documentation. But if you want to actually operate the platform, say with downloading data and running, then there is a need for a user account, and for that one has to apply as a beta user, and there is a setup with a scheme for that, which is available as you go into the first on the web page on EDITO Infra. The same is for Destination Earth and for EOSC. EOSC is available for everyone with a European academic account that are one of the national certified users. There's a single sign-on system behind that is unified across Europe. So that will work. And then you will get automatically the credit according to the academic status, even though there are some still updates of that going on the national levels. So that's
No worries.
basically
Thanks for
state of.
sharing that on. I got that link, so I'll be checking that out. Thank you.
Yep.
Thank you. Are you developing, can I ask, are you developing a digital twin for another region than Europe?
No, we are not developing digital twin, but this topic I'm joining for the very first time, and I felt it very interesting because what we are developing is a solution for marine protected areas.
Mhm.
And there we need to do dry run on a lot of data, and digital twins help us in evaluating those solutions.
Right.
So I would be looking at this detail from that perspective.
I see. Are you from Asia then, or is it the location
I
of this?
am so basically I am from India right now, and I'm working with Hub Ocean, which is from Netherlands. So that's how we are into this marine related solution.
I see. I see. Okay. Yeah. Thank you. Thank you for joining us. And a very good question that allowed Arne to explain in more detail how to make use of the resources and the status of availability of them. But as Arne said, there is no reason to wait long. There's a lot of information about it and a certain level that you will be able to benefit that you need to go through anyway. So let's see. There was also a question here. Yeah, what are the main differences? Atroulier, are you here with us? Yes, I see you are here.
Yes, I'm still with you.
Yes, thank you. So can you ask your question and then we can answer?
Yes, I work on Destiny for Agri-ST company, and I work on the services of adding some data set and information and create space to add data. And I never heard about EDITO, and when the EDITO was presented, I thought it was nearly the same. So I just asked this question because I'm surprised to see 2 big projects like that, because they require a lot of people, and just wonder if they are not duplicate and what are the differences.
Yeah, so I did answer that
Mhm.
earlier down in the chat. Of course, the underlying situation is that there are different funding agency and different responsible organization. But with Destination Earth having a focus of digital twins of the planet Earth, obviously the ocean is actually the majority of that, looking at the area, surface area at least. And indeed, the digital twins of the ocean is targeting that. So there are contacts and interactions between these initiatives, and the main alignment has been done from the satellite community on the use of STAC, spatial temporal asset catalogs. But there is also a history in the marine community with the Copernicus Marine Services and with EModet, the Sea Data Net. There is a lot of active collection of ocean-related data that is already in infrastructures. And these infrastructures are now being enhanced to follow this triangle model of the digital twin data lake and the engine and the services. And harmonization is being done on the technologies with respect to future interoperability, but it's built upon existing software from various organizations. So there will be some, say, duplication of effort, since not exactly the same software is being used, but it's at least aligned with respect to future interoperability and synergy, and hopefully that will continue, and there will be cross connections to make sure that we optimize the resources for the future as much as possible.
Yeah, and I might add that, you know, Destination Earth is, well, it's ESA, European Space Agency, it's EUMETSAT and ECMWF, so meteorological organizations. And in some countries, the meteorological organizations are covering both the ocean and the atmosphere. But in other countries, they are divided. So I just, you know, so the type of data might also be, or where the data is coming from might also be a difference here. Because in EDITO, it's focused around more ocean focused organizations, and they are very close linked to the Copernicus services. It's you know, it's a mix. And I saw James, you were suggesting that we should have an infograph or something to really paint this picture. And I think I totally agree with you. It's very difficult to maneuver and see the differences and the similarities, because there are overlap as well. So I think that will be helpful for those who are, you know, coming into this community and don't have the overview that some of us actually do have. That will be very helpful because it's difficult, you know, to maneuver, obviously. Yeah, did you have something more? Yeah, Atelier, you had a...
No, thank you for your answers.
Okay, thank you very much. Okay, do we have more questions? Yeah, Adam, you can, are you with us also, Adam? Yes, hi. We cannot hear you. It looks like you are unmuted, but the sound, you're probably having some...
Yeah, can you hear me now?
Yes,
yeah.
yes.
Yeah. Yeah, so I guess I do a bit of work, a bit of advisory work on some of the decade actions and some of the, and particularly ODIS. So I guess my question really was, you know, with developing the ocean information model, and I think Arne, you kind of answered this a little bit in the chat. What are some of the considerations with that Iliad and the ocean information model are putting into being interoperable with some of the work that's happening in the decade around ocean data and information system, particularly?
Yeah, so we have this ocean decade action called EDITO, Digital Twins of the Ocean, with 6 working groups. And in the framework, architecture framework group, we are working with interoperability aspects on these various initiatives. So in particular, working with Pierluigi Buttigieg, who is involved in this, and the ODIS approach using schema.org to represent resources. Obviously, schema.org is kind of web-based representation form and doesn't capture all of the semantics as you would do in linked data RDF representation. So we have various discussions on representation forms, but of course the content initially is also a focus. And one experiment has been done now with the EDITO resources to represent that in the ODIS context, also to look into applications or components and services and linking all that with resources, a little bit along the lines of what was presented with CWL and the application packaging. That's an alternative approach, not using schema.org in the workflows of that. So I think it's a little bit evolving on how to have interoperability across different representation forms here. And that's something I guess we have to live with as things are evolving. But it's obviously a strategy that the resources that one has here, both in EDITO and in Iliad, can be mapped into ODIS and be represented there in the same way as you see, for instance, in EOSC. The EOSC resource portal is very similar to ODIS. Not only data, but also software resources and tools and projects and all of this. So that has another representation form again, but there is no problem for a resource to be represented in multiple catalogs. So I think that will be the strategy, and also then federation of catalogs is something that can be discussed between, say, the catalog providers.
Great.
So at least we are working on it, but it's not like everyone uses the same system. We have to look at interoperability, and there is always some issues and some very interesting discussions on the semantic representation power of schema.org versus RDF, for instance. So we have
Yes.
some fun discussions.
Brilliant. Thank you.
Yes, and I think so continuous communication, both to get an overview and to know what is happening, and then drill down to very specific detailed discussions on format, etc. But all of this needs to happen at the same time, because the world is evolving super fast. So so continuous communication, and I'm very happy to see that there were so many here today, because this is Iliad's contribution to support this community interactions. So thank you, Adam, for joining us, and thank you for the question. And we will follow up with more webinars of this type, actually, and we will invite people from the different communities representing the resources that Arne was representing for us today, and additional resources. There are multiple infrastructures and resources that are going to be useful for when you develop a digital twin. And it depends on where you want to do it, what is the discipline that you are within, the thematics, etc., etc. So we will.
Bente, you might have, there is a question from Benjamin Branch here on a couple of questions. I count to see how it works. I guess as you presented multiple systems, the question is which, and as I mentioned, all of them have some availability without any user account, but for having a user account, one would need to apply as beta tester typically, and there are some procedures for that on each of the sites. The federation of data is, of course, a challenge that is being addressed to this so-called harmonized data access for the data lakes. And that's done by services you find in Destination Earth, as well as in EDITO, and also Iliad is dealing this on the federation with the Ocean Information Model that Raul presented. Satellite data is, of course, very fundamental in all of this. It's much driven by the satellite community, a reason why STAC is one of the preferred representation forms for raster and coverage, particularly for the ocean with Copernicus Marine Services, CMEMS, but similarly also with the European Space Agency in the context of Destination Earth and EUMETSAT. So satellite data is not only integrated, it's the basis, and there's more discussion of how other data is being integrated in addition to the satellite data. And that's some interesting discussion, because STAC is not necessarily optimal for vector representations that we have for other data. So there are ongoing discussions on how to have more polyglot data representations, and not only with coverage and cubes and satellite data.
Yeah, and the general for all the data inputs, all the data inputs federated, and in general, this is a challenge specifically for in situ data and also citizen science, both on the technical aspects, but also on more licenses and, openness questions. So we are working a lot all over this overview of this type of questions. There are many different levels, some political, some policy, and some very technical, to make everything work together. Okay, so with that, I don't see any more questions, and we are we are looking good in terms of time. As I said, we will have yet another webinar in the Iliad webinar series of this type, and that will be organized in early 2025. But already in December, on the second Wednesday of the month, we have the next webinar. So it's on the 11th of December. We will again address the commercial or the more sustainability issues related to maintaining and sustaining digital twins. We had one last month also, and then we will come back to that because this is an important part of particularly innovation actions that Iliad is. So we will come back to that. So just if you are not subscribing to the Iliad email list, please do that. Since you are here already today registered, you will get the invite for the future webinars as well. But do follow us in social media and let us know if there are any topics that you particularly would love us to address. And if you have suggestions for presenters, that we would very much like to hear that as well. Okay, with that, I think we can conclude. Thank you so much to all the speakers. It was very interesting, and you see that we are starting to get some very interesting results from Iliad that will be shared with the entire community. And there's a lot going on in Europe and the rest of the world that we also would like to continue to share with you. So thank you very much, and see you next time.